This is Josh White with JW Math Tutoring. Today's video is going to focus on the Math Section 3 No Calculator part of the March 2023 SAT QAS that was given on March 11th, 2023 here in the US. For solutions and explanations to the calculator portion of this test, please see a separate video, which will be linked below once it has been posted. And for a copy of this test to work along, please look in the description below. All right, so let's go ahead and get right to it.
But life is a dream the calculus could never predict.
All right, so just before we get started with the March 2023 QAS Math Section 3, the No Calculator section, just a couple things to keep in mind. First of all, of course, if you like this video, please do click the thumbs up on it, and of course, subscribe to my channel and sign up for notifications. Also, I try to go through as many possible solutions to these problems as I'm aware of. So that means that my videos will often be longer than the allotted time allowed for each section on an SAT or ACT exam. So do keep that in mind. Most likely the solutions to these 20 questions will not be done in under 25 minutes because on some of them I'll show multiple ways you could solve them. Okay, so problem number one, starting off, again, section 3, no calculator section from the March 2023 SAT. So here we have a very basic linear equation, and obviously to solve this you could just subtract 10 from both sides, and that would just give you x equals -7. And that's it, no other work is needed. The correct answer is B. Notice you could also do back solving on this, meaning you could take the answer choices and plug them in and say, okay, what plus 10 equals -3? But, it's really not any quicker or easier than just subtracting 10 on both sides and getting your answer that way. All right, now, next one, question number 2. So here we have a situation. Notice that basically here, like this equation they're setting up is the profit equation. It's basically revenue minus cost is equal to your profit. So the $50 that it tells you she made, that's what that's her profit. So you want an answer that's going to be equal to 50 in some way. So we can get rid of B and we can get rid of D. And then when you look at A versus C, so she charges $25 for each lawn, and we don't know how many lawns she mowed, so we're just going to use a variable for that, and they tell us here to use X in the problem. So the amount she would make from mowing lawns is just 25, times X. And of course, that's going to be the revenue, so that would come first, and then the $150, that's her cost. So you would subtract that from the money she brings in to find out how much overall profit or total money she would have left. Therefore, correct answer for this one is just going to be letter A. 25x minus 150 equals 50. Now, for number 3, here you have a system of equations. Probably the quickest way, or maybe the easiest way to do this, is to just go ahead and set each of these equations equal to each other because they're both already in slope-intercept form. So if you, just kind of scratch this out and we just make this, 18x plus 25, now we can go ahead and solve for x. So I'm going to add 14x to both sides, and that's going to give me 32x, and then I'm going to subtract 25 on both sides. That's going to give me -32, divide by 32, and we get x equals -1. Now, notice at this point, there's only one answer choice that has a -1 value for the x-coordinate, so we know by process of elimination the answer is going to be B. Therefore, if you were taking this test and the official, test date, you would want to select answer B and just move on. Like, there's no reason to spend any time solving for y unless you have extra time left over or you're, concerned you might have made a mistake when you were solving it. If there were multiple answers that had -1 for x, then yes, you would have to solve for y to figure out which one of those is correct, but you don't have to do that here. Now, you can easily see if you plug in -1 for x, say, into the top one, 18 times -1 plus 25 is just going to be -18 plus 25, and that will just equal 7. Okay, so that confirms -1, 7 is the correct answer. Last thing on this problem, an alternate way that you could solve it is you could technically take each of these points or these answer choices and you could plug them in to the given equations, plug in the x value and the y value and see if they're equal. But the only problem with that is, A, this is a no calculator section, and some of these numbers are quite large, like -7 or 7. You got to know what 18 times 7 is, or 14 times 7, and most people don't have that memorized off the top of their head. Or like in the last one, 25, 18 times 25, 14 times 25. And B, in order to determine the fully correct answer, I mean, it has to work in both. So some of these might work in like one equation, but not the other. So that, for this specific problem, that would probably not be a quicker or easier method. But just be aware it is, an alternate method you could use to solve it. All right, now going on to problem number 4. So scrolling back up here. Here we have a formula with a bunch of letters a, b, x, and y, and they basically want this to be solved for a. So first thing I'm just going to do is just add y to both sides and get ax equals bxy plus y, and then just divide by x, divide everything by x. And now, before I would try to do any simplification or like maybe split this up into two individual fractions, I'm going to look at the answer choices and notice that A matches this perfectly. So the correct answer is going to be A. Now, an alternate method you could use here is picking numbers. You could choose values basically for A, B, X, and Y. I mean, really what you would probably want to do is you would choose you would pick numbers for 3 of the letters and then figure out what the 4th one would be in order to make the statement, the original equation true. And then you would go down to the answer choices, like plug in those values you chose, most likely for b, x, and y in step 1, and then see which of those came out to the correct a value in these formulas. Again, because it's no calculator, and because the actual work involved in solving this here is pretty easy, just add y and divide by x, I would not recommend that method, but again, it's an alternate method you could use. All right, number 5, you are given a quadratic function here, and it basically says h of 2 equals 0.4, means what? So notice here, the function is, h of t. So when we see h of 2, that means that t is equal to 2, or in other words, 2 represents a time or a number of seconds. So when we go down through these answer choices, the first one doesn't mention anything about 2 seconds. Second one doesn't mention anything about 2 seconds. It talks about 2 meters, but not 2 seconds. The third one does mention 2 seconds, so we would keep that for now. And then the fourth answer does not mention 2 seconds. So by process of elimination, it's going to be C. And this basically makes sense, right? T represents the time, so 2 seconds, and 0.4, what it's equal to, or the output, represents the height. So at 2 seconds, the height of the ball is 0.40 meters, off the ground. So correct answer is letter C. Moving on to problem number 6. So for this one, we have absolute value equations. This one, there also, again, are multiple ways to solve this. So the way you would most likely learn to solve this in school is you would first add 9 to both sides, and then you've got absolute value of 15 minus x equals 9. You would set up two equations. The first one looks like the original problem minus the absolute value signs. Second one looks like the original problem, but you make the right side negative. Then you solve each of these. Basically just subtract 15, and then you're going to divide by -1. So we get one answer of positive 24. The steps are the same for both of them. So here we get, looks like positive 6. So we get two answers, positive 6 and positive 24. So looks like the correct answer to this problem is going to be letter D. Now, an alternate method you could use on this problem is, again, back solving, because we have an equation here and we have the answer choices. So you could take these answer choices, you could plug them in for x, and work them out and see, you know, okay, 15 minus what? Basically, you're looking for something that's going to equal either positive 9 or negative 9, right? So it's like if you start with A, you do 15 minus negative 6. That's equal to 15 plus 6, which is 21. Absolute value 21 is 21. 21 minus 9 is not 0, it's 12. So like the first two would be out because of that. And then the last two, you'd have to figure out whether it's positive or negative 24 that you would, you know, plug in to answer it. So if you don't remember how to set up and solve absolute value equations, that's fine. Use back solving, you know, basically plugging in the answer choices. All right, now for 7 with this graph. Basically, what makes this a little trickier, what's going on here, is that they want to know how many paper flowers Lucia can make per hour. So what you have to basically realize is that at this point right here, the y-intercept, where Lucia spends 12 hours, since she, since at that point, you know, the total made between them would represent 60 flowers because every point on this line represents a possible combination of hours to make 60. If you do 60 flowers divided by the 12 hours she works alone, she would be making 5 flowers per hour. So the correct answer is going to be letter B, 5. Question number 8, here we have a graph of an exponential function, and they tell us that this graph here is actually the graph of f of x minus 1. So what that means is this is the graph of f of x, but it's shifted down 1 unit. So in other words, the actual graph of f of x will basically be up, you know, like 1 point from everything that we see, you know, on the screen here. So in other words, if I were to draw, you know, a bunch of points all 1 unit above the corresponding x value, like this is the actual graph of f of x right here. Okay, and now they want to know which of the functions could define f. So my recommendation for problems like these, where you're given some graph and they give you, say, the equations, in other words, they want to know what the equation of the function is to find points that you know are on the graph, on the function, and then plug those into the answer choices. So for example, the actual function f of x, which is shifted up 1 unit from f of x minus 1, will go through the points 0, 3 and 1, 4. Okay? Because again, this graph is the original function shifted down 1 unit. So if I shift it back up 1 unit, I'm back on the original function itself, f of x. So 0, 2 goes up to 0, 3. 1, 3 goes up to 1, 4. Now, go through these answer choices, plug in 0 for x. Notice that 2 to the 0 is just 1. So this is 1, this is 1, this is 1, and this is 1. Okay? So now, what do I get? 1, 0, 2, 3. So which of these has the point 0, 3? Well, it's letter D. So correct answer here is y equals 2 to the x plus 2. Now, if you're pretty familiar with exponential functions, I mean, you might recognize that this actual function graph right here is 2 to the x plus 1. In other words, 2 to the x will go through 0, 1 and 1, 2 right here. This function is shifted up 1 unit from that. So if you would go ahead and shift it up 1 unit, like 2 to the x up 1 unit would become 2 to the x plus 1, and then shift it up another unit to get the original function would make it 2 to the x plus 2. So you could figure it out that way, but I think it's so much easier to just find a point or two that's on the function, you know, the graph of the function, and plug that into the answer choices and see which one it is on or it works for. Okay, question number 9. Here we have a equation for the standard form of a circle. It's not yet in standard form, but we're going to put it into standard form. And basically what's going on here is we have a square, we have the circle inscribed in a square, and they want to know what the perimeter of the square is. So what we have to do is put this circle into standard form by completing the square. So first I'm going to move the negative 47 over to the right by adding it, and then I'm going to put some blanks. And now I take the b term for both the x and the y's and I square them. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. That goes in this blank. And then I add the same numbers on the right. Now, technically you don't need to do the rest of the work on the left side because you don't need the center of the circle. All you really need for this problem is its radius. But I'll just show you. Basically, this circle in standard form would look like this. And now on the right side, if you add up 47 and 25, you will get 72, and 72 plus 9 will be 81. So now it's in standard form. Technically, again, you don't need this for this problem, but the center would be 5, 3. The radius would be the square root of 81, which is 9. So what that means is, here we have the circle inside the square. We have a radius here of 9. We have a radius here of 9. Therefore, this side of the square, which will be equal to the diameter, is 18. Therefore, the perimeter is just going to be 18, times 4. And that means the perimeter of our square is going to be 72. So the correct answer for this one is going to be letter C. Moving on now to problem number 10. Here we have some rational exponents. So on this problem, first thing I'm going to do is I'm going to rewrite all of the numbers and letters inside the radical basically to the 1/5 power, because that's the same thing. So we have 32a cubed b to the 4th, and we could say the whole thing is to the 1/5 power, because the 5th root of something is the same as 1/5. Now, basically, what you have to know or have to recognize is that, first of all, 32 to the 1/5, or in other words, the 5th root of 32 is just equal to 2. Because if you take 32 and break it up, it turns into 5 2's. It's like 16 times 2, and then 16 is 8 times 2, and 8 is 4 times 2, and 4 is 2 times 2. So there's 5 total 2's. So the 5th root of 32 just simplifies to 2. And then for the a and the b variables, well, here we just multiply, like a to the 3rd, 3 times 1/5, 3/5. 4 times 1/5, 4/5. So correct answer for this one is just going to be letter A. All right, now looking at problem number 11 at the bottom of the page. Here you have a cone with a hemisphere, which basically half a sphere on top of it. And they're asking for the total volume of this entire configuration. So if you don't have the volume formulas for each of these figures memorized, that's fine. They're actually given on the test, on the first page of each section. So for the cone, you've got 1/3 pi r squared h. For the sphere, you've got 4/3 pi r cubed. Now, notice here the 6 centimeters is the diameter of both the cone and the sphere, which means that the radius, will be 3, because it is half of the diameter. Also notice that because the radius is 3, that means starting at the center here and going out in every direction, including going straight up here, will be a distance of 3 centimeters. What that tells us is that the height of the cone will be 6 centimeters, because the overall height is 9, but when you take away the 3 centimeters, or the radius of the sphere, that leaves just the height of the cone to be 6. So now we can just plug those values into each of the formulas and then add them together and get our final answer. So for the cone, we are just going to have 1/3 times pi times 3 squared times 6. So 3 squared is 9. 9 times 6 is 54. 54 divided by 3 is 18, and you get 18 pi. Note that you could also like cancel out this 3 and then just get rid of the squared, and then you could just do 6 times 3 and get 18 that way, if it's easier to think about it. Now, for the sphere, notice that I'm going to calculate the area of the entire sphere and then just divide that by 2 for the to get the area, the volume, not the area, volume of the half a sphere on top, or the hemisphere. So we have 4/3 times pi times 3 cubed. Now 3 cubed is 27, and then what I would do is I would just go ahead and I would reduce the 3 into 27 first and make it 9, because it's much easier to multiply 9 times 4, which is just 36, rather than doing 4 times 27, which is 108, and then dividing that by 3. So it turns out that the volume of the sphere is 36 pi. But again, remember, that's for the entire sphere, okay? That is not for half of a sphere. So now we have to take that and we have to divide it by 2 to get 18 pi, which will be the volume for just the hemisphere on top. So total volume of both things together, we've got 18 pi for the cone plus 18 pi for the hemisphere, 36 pi. The correct answer will be letter B. Now, moving on to the next problem, number 12. Here we have some fractions that are just being squared using FOIL. So I would just write this out. And now, like I said, you could just go ahead and FOIL these. So if you notice, a over 4 times a over 4 is going to be a squared over 16. Okay, so far we can eliminate this and we can eliminate this, okay, because they both have a squared over 4, which is wrong. That's the first term. Then the inner and outer terms are each going to be identical, because they're each going to have an AB on top and a 12 on the bottom. And then the last two terms right here, it's going to have b times b, b squared, 3 times 3, 9, b squared over 9. So notice it's going to be letter D. And just so you know, the reason that this combines to be ab over 6 is because technically it becomes 2ab over 12, because you have a 1 here that's not written and a 1 here. 1 plus 1 is 2, and then the 2 and the 12 cancel to make 6. So correct answer for this one is going to be letter D. Now for number 13, here you have a system of linear equations. Although they only give you one equation, they ask what the other one has to be if you're told there's only one solution, meaning that these two lines intersect one time. So what that means is these lines will have different slopes, okay, because they only intersect one time. So there's multiple ways you could do this. You could either put them all into slope-intercept form and then compare that to the slope of the first one. So for example, the first one you get negative 2y equals negative 2x plus, that should be plus 2, and then divide by negative 2. So we get y equals x minus 1. That's, again, this equation right here in slope-intercept form. Then you could go through all these and see, okay, basically 3 of them are going to have a slope of 1, and 1 of them is not going to have a slope of positive 1, and that one that does not have a slope of positive 1 will be the correct answer. But the way I like to look at this, or figure this one out, is because all of these equations are in standard form, that means the multipliers from the x and the y terms have to be different, because there is only one solution. When there's infinite solutions or no solution, the multipliers between the x and y terms in standard form are the same number. So what that means is, like looking at the answer choices, you know, from here to here it's times negative 4. But notice from here to here it's also times negative 4, right? Negative 2 times negative 4 is positive 8. So this one is out because it has the same multiplier on both terms. The same is going to be true for b. It's going to be like 1.5 for both the x and the y. And for d, it's going to be like negative 1/2, you know, going from the top equation to the bottom. C is going to be the correct answer, because to go from 2 to negative 10, it's like times negative 5. but from -2 to +8, it's times -4. So the multipliers are different, therefore the slopes will be different, therefore there's only one solution. C is the correct answer. Now, number 14, I'll have to zoom out here so we can see all of the possible answer choices. You have a rational function, and they want to know which could be the graph of it. So, a couple things to keep in mind here. First of all, there's going to be a vertical asymptote at -2 because we set the denominator equal to 0 and solve. So when we look at these possible answer choices, okay, the first one looks like there isn't a possible asymptote at -2, so A, we keep it. B, we eliminate, it's wrong. C does have an asymptote at -2, so we keep it. And it looks like D could also have an asymptote at -2 as well. Now, the next thing that we can look at here, we could look at the horizontal asymptote. So because the degrees on the top and bottom are the same, they're each x to the first, the horizontal asymptote will be -4/1. It goes to the leading coefficients. So in other words, y equals -4. So when we look at the possible answer choices here, A does not have a horizontal asymptote at -4. You know, that would be like basically somewhere down around here. So that one's out. C does not have a horizontal asymptote at -4. Again, that would be like down here below the x-axis. D does look like it has a horizontal asymptote of -4, and it's also correct just by, process of elimination. Notice another thing you could do if you just forgot about the horizontal asymptote is you could also plug in 0 for x to get the y-intercept, and it turns out that the y-intercept is going to be 8. In other words, it's going to be 0, 8. So you could also look at the graphs and see which of these crosses at what looks like 0, 8. It's going to be D as well. So there are multiple properties of this rational function that you could look at to determine, which graph is going to be the correct one. All right, number 15. Here we have an exponential function, and they just want to know the y-intercept of this graph. This is a very, very, very easy, basic problem. Y-intercept, I just talked about it. We plug in 0 for x, so 5 to the 0 is just 1. 1 plus 3 is 4. It's just b, 0, 4. And that's it. Really no other work needed. All right, now moving on to the grid-in questions, basically the free response. The first one, what is the slope of this function? So notice it's in slope-intercept form, y equals mx plus b, so m is obviously just 30. Correct answer is 30. That's it. Just grid it in. No other work to do. Okay, next problem. Here you are given a function. Notice this is also a line, but that doesn't really matter. And they want to know for what value of x does it equal 1. So this is basically saying when y is equal to 1, what is the corresponding x value? So just set it equal to 1 and solve it. I would multiply everything by 10 on both sides. That will clear out the fractions on the right, because 5 will go into 10 2 times. So I got 2x. 10 will go into 10 one time, and therefore I'll be left with a 9. Go ahead and subtract 9. 1 equals 2x, divide by 2. So for this problem, there's two answers you could give. You could grid it in as 1 divided by 2. You could also grid it in as 0.5 or 0.5. Either one would be acceptable. All right, for 18, here you have basically a line, and they give you its slope, but its slope is a formula, basically with a variable, and they give you its y-intercept, which again has a variable in it, and they want to know, what the x-coordinate of this line is. So there are multiple ways you could do this. First, I'll show you the theoretical way, and then second, I'll show you the picking numbers strategy. So the theoretical way I would do this, zoom out to make it a little larger here, would be to say, okay, the slope, which is negative 2p over 5, is equal to basically y2 minus y1 over x2 minus x1, right? The 2 points I'm going to use are going to be the x-intercept and the y-intercept. So the y-intercept is 0 comma p. The x-intercept is x comma something. Okay? Sorry, x comma 0. We know that the y value is 0. It's the x value that we don't know. So now, if you plug these into the slope formula, so subtracting the y-coordinates, you get p minus 0. Subtracting the x-coordinates, you get 0 minus x. Okay? And you're probably, wondering, like, what's going to happen here because we have multiple variables, but don't worry, I'll show you. We're still going to be able to solve this. So we get negative 2p over 5 equals p over negative x. Now, what I would do is I would cross multiply. So that would give me positive 2px equals 5p. Because p is a positive number, non-zero number, we can technically divide both sides by it, and it will cancel out. And we get 2x equals 5, or x equals 5 halves. So the correct answer is 5 halves. You could grid it in as 5 divided by 2 or 2.5. Either one is correct. Now here's an alternate way to do this if you wanted to choose picking numbers. So what I would do if I wanted to do picking numbers is I'm going to let p equal 10. Okay? I'm just going to do the work over here on the side. So that means the slope for this would be negative 2 times 10, which is negative 20 over 5, or negative 4. It also means the y-intercept would be 0 comma 10. So therefore, if I know the slope of this line and I know its y-intercept, now I can just write its equation. Y equals negative 4x plus 10, right? So what is the x-intercept of this line? Well, just set y equal to 0 and solve for x. Subtract 10 on both sides. Negative 10 equals 4x divided by 4. You get negative 10 over 4, which you would have to know to reduce to negative 5 halves, again, or the same negative 2.5. So this is an alternate method, but picking numbers, but you do have to recognize just to pick a number for p that's easy to work with. Like the reason I picked 10 is because it makes the slope a whole number. It comes out to negative 4, right? As compared to like 1 or 2 or 3 or something like that. So there's two ways you could solve 18 to get the x-intercept. All right, 19. This is one of the trickier questions on the test. So basically, what's going on here is you have like this thing right here, right? And here's point G, and like this is x, whatever, this is y. So what you have to know in order to get this one correct is the idea that if you have two angles which are complementary, in other words, if you have two angles together that add up to 90 degrees, like the cosine of one equals the sine of the other, and vice versa. The sine of one equals the cosine of the other. The reason that works out is because if you think about it, say here's a right triangle, and say this is like 40 degrees, and say this is 50 degrees, right? And just, I'm just going to pick numbers. These are probably not accurate numbers based on the triangle itself, but just assume this was like 3 and 2, and then this would be, whatever, square root of 13, just hypothetically. So notice that the cosine of 40 down here, say this was x and this is y. The cosine of 40 is adjacent over hypotenuse, which would be 3 over root 13. Okay? But notice if I also did the sine of 50, I take the opposite, which is 3, over the hypotenuse, which is root 13. So notice the cosine of one angle is equal to the sine of the other angle, and both angles add up to 90 degrees. And the same is going to be true if I do the sine of 40, which is 2 over root 13, and the cosine of 50, which is also 2 over root 13. So if you know that, what happens here is that you could substitute in, like, the sine of y is just equal to the cosine of x, and this is just going to be equal to 0. Now, so that's the final answer, 0. You just grid in 0. An alternate way you could do this, if you have memorized the values for, like, the 45-45-90 special right triangle or 30-60-90 special right triangle, like, say that you split these two angles up, this right angle up into two 45-degree angles, right? Therefore, the cosine of 45 or in other words, cosine of x, cosine of 45 comes out to be root 2 over 2. The sine of y, or the sine of 45, is also root 2 over 2. Again, this you would get by memorization or by knowing the special right triangles, the pictures of them. And root 2 over 2 minus root 2 over 2 is again 0. So if you didn't remember or didn't know this property that I talked about initially, the way you would have to solve this is you would have to basically give values for x and y such that it's like that they're each 45 45, or maybe it's like 30 and 60, and then find the cosine and sine values for a 30 or a 60 or a 45 that you have memorized from those special right triangles, and when you plug them in you'll see that they're the same and they give you 0. Now, for number 20, this one, the easiest way to do this is to have memorized the shortcut formula, which is that the sum of solutions to a quadratic equation is always going to be equal to negative b over a. So all you have to do is you would do the opposite of negative 2 over a, which is 3, and that just becomes 2/3. So correct answer, 2/3, or 0.666, truncate the decimal, or 0.667, round the decimal. Any of these three forms would be acceptable. If you didn't do that, basically what you would do is you would go through and you do quadratic formula. I'm not going to bother doing all the work for it, but just I'll let you know that if you work it out, it comes out to like 2 plus or minus should be root 93 over 6. And then technically your two answers are 2 plus root 93 over 6 and 2 minus root 93 over 6, right? So the question says, what's the sum of these solutions? Well, if you add these together, notice what happens is the 2 plus 2 gives you 4, so have the same denominator, but root 93 plus negative root 93 cancels out. So you get 4 over 6, which is just 2/3, or 0.666 or 0.667. So you could technically solve it that way, but it's just so much easier to just memorize this formula. Just like there's also the formula for the product of the solutions, which is C over A. So those are all 20 questions on the no calculator section from the March 2023 QAS. This is not from the school day test. This is from the Saturday, test given on March 11th. So if you have any questions, comments, or concerns, please leave them in the comments below. Of course, if you like this video and my other math videos, please do give it a thumbs up and subscribe to the channel and sign up for notifications. Otherwise, I'll be back to post the full solutions to the calculator selection coming up here shortly.